And I asked one of my students if their kitchen is a laboratory. The question at first looked tricky, and he almost said no. But then he said, yes, kitchen is a lab. And then I asked him, how is kitchen a lab? He went ahead to mention the reactions that happen in the kitchen. And you know that the kitchen is the busiest laboratory in your house. Like, have you taken your time to observe how much chemistry reactions that happen in your kitchen? So today we're going on a kitchen tour. Let's try to find out the reactions that happen in our kitchen, how they happen in the kitchen, and what brought about these reactions. Remember, this is Chem Ella Lab, the home where chemistry plays a script. And today we are going to play a script scene by scene. So get your popcorn and sit down because this video is going to be exciting. Hi everyone, welcome to my channel. I'm Ciela and this is Chemistry with Ciela. Come with me as we go on a kitchen tour. The first chemistry reaction that happens in our kitchen is combustion. Now let's try to on our gas, and when you try to on your gas and then boom, you observe a fire. The fire came as a result of your gas reacting with the oxygen that is free in the air. This reaction is called combustion reaction, and it is simply an exothermic reaction, meaning that energy has been released to the atmosphere in form of heat and what? Light. And have you ever thought that without this combustion, can you boil rice? Will there be boiling of water? Will there be frying of egg? Absolutely not, because combustion is the first chemistry that happens in our kitchen before any other thing happens. Okay, so without combustion, there will be no boiling of water, there will be no frying of egg, there will be no frying of dodo, and there will be no hot water for tea. All right, so this is the first reaction that happens in our kitchen. All right, so let's move on to scene 2. Now let's try frying some eggs. Okay, you pour out the egg and you observe that the egg yolk is very clear and crystal and nice. Now what happens few minutes later, you observe that it has changed color and it has changed shape. Now it has moved from that crystal color to a firm white solid. What happens? This is simple. The amino acid present in the protein has changed the natural three-dimensional shape to a more new arrangement, still maintaining the peptide properties. Okay, so this process is called protein denaturation. Protein denaturation. The reaction came as a result of amino acids in the protein changing its shape from the normal, from the three-dimensional shape to a new arrangement. Okay, that is why a boiled egg can never be transformed back to a raw egg, because the shape has been changed. Okay, so without this reaction, you cannot eat fried egg, you cannot eat boiled egg. Without protein denaturation in your kitchen, there will be no boiled egg, neither will there be a fried egg. So this is second reaction that happens right in your kitchen. So moving on to the third scene we have today. So let's try toasting bread or roasting meat or even fried dodo. Okay, so you have your plantain, you have your oil, and you have everything. Now, how did that brown color happen? Did you add some ingredients there? Did you do anything there? Was there any magic? Was there any abracadabra in the kitchen? There was no abracadabra. What just happened is what we call a Maillard reaction. Now, Maillard reaction is a process where the protein reacts with sugar in high temperature, leading to a formation of aroma compounds. These compounds are responsible for the sizzling smell, for the browning color, responsible for the flavor of the toast, which is why a toasted bread tastes different from a fresh baked bread. Okay, and so when somebody says, oh, this food is delicious or this food smells amazing, please say chemistry is involved, because chemistry happens everywhere around you. Okay, so these compounds, this aroma compound, came as a result of Maillard reaction, which is simply a reaction between the protein and the sugar at a high temperature, that's above the normal temperature. Okay, and this is responsible for the coloring, responsible for the sizzling aroma and sizzling smell of grilled meat, and also why the dough is fresh and smells good. All right. So moving on to scene 4, the fourth reaction that happens in our kitchen is acid-base reaction. Acid-base reaction is simply a reaction where an acid reacts with a base to produce salt and water, and carbonates of this acid and carbonates of this base in the process will also release carbon dioxide. Okay, so this reaction doesn't only happen in your textbooks, it happens in your kitchen. Okay, let's try baking some bread. What happens when you bake bread? The baking soda present in the bread will react with acidic ingredients like the yogurt, the vinegar, or the lemon juice, and this will lead to a release of carbon dioxide. These tiny bubble gases will be trapped in the batter. It will not be released to the atmosphere, rather it will be trapped in the batter. Okay, so when heat is applied to the batter, it expands, and this is responsible for the soft, fluffy, and light weight of bread. Without this release of CO2 in the atmosphere, and without this release of CO2, and without this acid-base reaction in your kitchen, you'll notice that your bread will be as strong as a stone, and I'm sure that a bread that is like that doesn't taste good. Okay, so acid-base reaction also happens in your kitchen when the baking soda reacts with what acidic ingredients, leading to release of CO2. But this CO2 will not be released. Rather, it will be trapped in your bread, which will expand and is responsible for the soft and fluffy nature.
Action!
The fifth reaction that happens in your kitchen is the oxidation reaction. Now let's try cutting some apple fruit and leaving it for some while. You get to observe that the apple will start changing color. This changing of color is what we call enzymatic browning. Okay, because the compounds in the apple is reacting with oxygen that is free in the air. Okay, so let's try creating another scene. Squeeze a fresh lemon juice on another slice of an apple, okay, and observe how the browning slows down. Why does it slow down? Because the acid in the lemon juice is reducing the activity of the enzymes. Okay, so instead of the quick browning, unlike the first apple you slice, you observe that this other apple, the browning of this other apple is lower because the acid from the lemon juice has reduced the enzymatic activity in this other compound. So when you notice the browning of the fruit, it's simply oxidation reaction. And oxidation reaction is a process of electron loss, oxygen gain, or is a process where a compound reacts with oxygen, okay, leading to formation of what? A compound with oxygen. One of the 6 reactions that happen in our kitchen is fermentation reaction. Now this reaction is simply where some microorganisms such as yeast feeds on sugar, and when they feed on sugar they release what we call CO2. Okay, so this CO2, like I want to bake my bread, this CO2 also will be trapped inside, and when the heat is applied, such as what happens when we are trying to bake a cake, when we are trying to bake a cake in the acid-base reaction, in this fermentation process, the yeast now feeds on the sugar. Okay, and when it feeds on the sugar, it's converted to what? Alcohol, in the absence of what? Oxygen. And this will also lead to the release of CO2, which will be trapped inside the dough, leading to an expansion of the bread. Okay, but I want to clear something. Now there's a difference between chemical reactions happen in our kitchen and physical change happening in the kitchen. For instance, boiling of water is a physical change, not a chemical change, because no new substance is formed. Rather, the application of heat changed the matter from a liquid form to a gaseous form. No new substance is formed. Okay, so when you see your kitchen, don't just see it as a normal kitchen, see it as a laboratory. When you look at your kitchens, see proteins defolding, see molecules forming, see acid-base reaction happening in your kitchen, protein denaturation happening in your kitchen. Okay, don't just see it as a normal place or a normal space. See it as also a room where chemistry plays a script. So Chemistry doesn't only happen in your textbooks, it happens everywhere, from your kitchen to your bedroom to your bathroom to your car, even in your batteries and your schools also. So in my next video, I'm going to tell you how chemistry made me a household entrepreneur. So when you understand all the reactions that happen in your kitchen, trust me, chemistry will become very, very simple for you. So thank you for staying to the end of this video, and see you in my next video. Bye.